When we're trying to square root a number that doesn't square root well, like say the square root of 72, the first thing we'll notice is that it's not among our perfect squares. So what we want to do is have the list of perfect squares in mind, or maybe on your paper. I would say these two perfect squares are not so important to think about, because our next part is to find the largest one of these numbers that will divide this evenly. And the goal is to square root a number that I know how to square root. And we're going to use this property that says if you have the product of two things that are being square rooted, you could break it up over the product. So we'll look at this list. We're going to start high. So I know 64 doesn't go into 72. I know 49 doesn't go into 72. Or maybe it does. If I wasn't sure, I could take out a calculator and I could see if if 72 divided by 49 was an actual clean value, but it's not. So I'll continue to work my way down. I'll try this 36. Maybe 36 goes into 72. If I'm not sure, I can check my calculator again. I get a nice number like 2. This means that 72 can be written as the perfect square 36 times 2. Now I can use this property to break this up. And we're going to square root the part that we can. I know the square root is 6. This I don't know. That's root 2. That's a simplified version of the square root of 72. Similarly, if we have something like the square root of 5 times the square root of 10, I want to clean this up too. There's too many radicals here. It's too messy. I'm going to use this property again, but I'm going to use it in reverse. We have this version of things. I'm allowed to rewrite this as the square root of 5 times 10, which would make the square root of 50. It looks a little better because there's just the radical here, 1 instead of 2, but I want to see if I can simplify this. So again, the first thing I'll notice is it's not in my list of perfect squares. So I'll start high and I'll work low. 49, that won't go into 50. 36 won't go into 50, but 25 definitely does. So I can take that 50, break it up as a perfect square that goes into 50, and whatever will be left. Break that product up into root 25 times root 2, square root the part that I can, and then have a root 2. So for this basic simplification, the idea is only the perfect squares are numbers we know how to square root, and so when your number under the radical is not one of those, you need to find the biggest one of those that divides it evenly, if there is one, square root the part that you can, and leave whatever's left underneath the radical. There's other rules about denominators and other videos that you'll see, but this is a good basic first step. Square root the part that you can, leave the rest alone.